Welcome to this lesson on equivalent expressions, part 2. Please make sure you have these notes in front of you so we can begin our lesson. And my students, let's make sure we update our table of contents. This lesson has two learning objectives. The first one says I can simplify expressions with one variable, and the second one says I can simplify expressions with two variables. So on the left-hand side of our key concepts, let's go ahead and discuss these images. So it says look at the images below. So we've got an image of a dog, a person barbecuing, another dog, a lady, and a car. So they want us to separate and combine these into categories. So the first thing I notice is I have dog, dog, dog. Well, I have 3 dogs. All I did was I combined the items that were like. So all the dogs are alike. So I have 3 dogs total. And then I have human and human. So then I have 2 humans. I just combined the items that are alike. And then the last thing is I have 1 car. So all I did was I combined items that look similar. I've got 3 dogs, I've got 2 humans, and I have 1 car. The vocabulary I want you to know is called like terms. Like terms are terms with the same variable and raised to the same power. Also, like terms are constants. So any type of constants will be like terms. So let's go ahead and take out some different colors so that we can color the different terms and color the like terms the same color. So I'm going to take a red color and I'm going to color every single term that is alike to be red. So 3x to the second power, I'm going to color red. So I'm going to look for another term that has x to the second power. And the next term that I see would be positive 2x to the second power. So those are going to be red because they have the same variable and they have the same exponent. Nothing else can be colored red because the other terms do not have the same exponent. So now I'm going to take a blue color and I'm going to go ahead and color another term blue. Now the first term I'm going to color blue is 6x. So I'm going to take a look at any other term that has the same variable. And I see this term right here. 3x has the same variable, so these are like terms. So now I'm going to take another color and I'm going to color my constant. My first constant I'm going to color green will be -4. So another constant that I have would be positive 8. Since these both are constants, I'm going to color them the same color. So now using the commutative property of addition, I can go ahead and switch these items around to look like this. So notice now all the reds are together, all the blues are together, and all the greens are together. So let's use these key concepts to discuss the following examples. Example 1 to simplify the expression to write an equivalent expression. So let's take a look at our variable terms. We can assume that there's an imaginary 1 standing in front. That's our coefficient for y. We can find another coefficient in front of that variable, and there's another coefficient of 1 that stands in front. So that's assumed that there's a 1 standing in front if you don't see any number there. Then I colored every term that had a y in it the same color because those are like terms. Then I colored the 25 in a different color because the 25 is a constant. It is a different term from the green terms because there's no variable next to the 25. So using the commutative property of addition, we can rearrange these tiles to look like 1y plus 1y plus 1y plus 25. We can put all the greens together, and we can put all the blues together. So now we can combine all the green tiles. We know that 1y plus 1y plus 1y is equal to 3y. And we can just drop down the plus 25 because we cannot combine them. Those are two different terms. So we can leave our answer as 3y plus 25. Please know that 3y plus 25 is equal to y plus 25 plus y. They're the same thing, they just look different. These are two equivalent expressions. So now let's take a look at the problem on the right. We can assume that there is a imaginary 1 as the coefficient in front of all of our variables. And let's go ahead and color the variables the same group color. So this is in one group, here's another group, and here's another group. I'm going to change the color and color the positive 25 in a different color because it doesn't have a variable. And I'm going to go ahead and combine these like terms. Now the only difference is, now that I've combined them, this is repeated multiplication, and repeated multiplication can be written as y to the third power plus 25. So because these are grouped into two different categories, one has a variable term, the other one does not, I have to leave the problem as is. So please know that y to the third power plus 25 is the same thing as y times y times y plus 25. These are equivalent expressions. So go ahead and pause the video and complete these got it problems, and we'll discuss the answers in class tomorrow. Notice there are two parts to this got it problem. There's the part on the left hand side and there's the part on the right hand side. Example 2 says simplify the expression to write an equivalent expression. So we can go ahead and we know that anytime that we have parentheses next to a number, this means multiplication. So we can write it like this: 4 times parentheses 6 times x. That's the same exact thing as what we have here. The only difference is we just put dots in there to represent multiplication. So now, using the associative property of multiplication, we can do this. We can have the same exact numbers, 4 times 6 times x, and I can group these two together. That's using the associative property of multiplication. Now we can combine like terms. 4 times 6 is 24. And then we can drop down the times x. Now we don't necessarily need that dot to represent times or multiplication, so we can just write it as this: 24x. So this is our answer. We simplified the problem. So please know that 24x is equal to 4 times 6x. They're the same exact thing. We just simplified them. These are two equivalent expressions. So let's take a look at example 3. It says simplify the expression to write an equivalent expression. So anytime you have parentheses like this, let's get rid of them using the distributive property. So I'm going to take the 3 and I'm going to distribute it to the k, and I get 3k. Let's take the 3 and let's distribute it to the 1, which is 3. So 3 times 1 is 3. And let's drop down the last k. So now that we've got rid of our parentheses, we can go ahead and color like terms. This term I'm going to color using green because it has a variable of k. The other term that has a variable of k would be this one. But notice there would be an imaginary 1 as our coefficient standing right there, so that would be imaginary 1k. Then I'm going to take a different color and I'm going to go ahead and color my constant, because constants are different terms than terms that have variables. So now let's use the commutative property of addition to switch the tiles around. We can place the green tiles together. Now we can combine like terms. So 3k plus 1k becomes 4k. And I can just drop down the plus 3 because that cannot be combined with it because there are no variables there. So please know that this cannot be simplified further. And this is equal to the original problem. Those are two equivalent expressions. So go ahead and pause the video and complete these got it problems, and we'll discuss these answers in class tomorrow. Notice this slide has two got it problems, got it problem B and got it problem C. So for example C, it says simplify the expression to write an equivalent expression. So the first thing I want to do is I want to go ahead and color all the like terms one color. So I'm going to choose green, and anything that has x to the second power, I want to color in green. So this tile has 3x to the second power. And the other like term would be plus 2x to the second power. I'm going to change my color now, and I'm going to select plus 9x. That's one term, and there's no other terms that look like that because the last term that I have left is a constant. So I'm going to color that last term, -5, in a different color. So now using the commutative property, let's go ahead and switch these tiles so that all the tiles that look alike are next to each other. So now that we've grouped all the like tiles together, let's go ahead and combine them. I can combine all the green tiles. or all the green terms. So 3x to the second power plus 2x to the second power becomes 5x to the second power. So then I drop down the rest of the problem, because none of the other terms can be combined. They're all different terms. So I can leave my answer like this. And please know that this answer is equal to this one. They're equivalent expressions. All we did was combine like terms. So pause the video and complete this got it problem, and we'll discuss the answers in class tomorrow. Example 5 says simplify the expression to write an equivalent expression. So for this problem, our learning objective changes. It says that we're going to simplify expressions with two variables. In the previous slides, we've only had one variable. So we're going to go ahead and combine these like terms. So the first thing I would do is I would go ahead and use the colors to go ahead and color my like terms. So I know that 14y is one term, and another term that looks like 14y is positive 22y. And the reason why these are the same is because they have the same variable. I'm going to take another color. I'm going to color plus x by a different color, because these are different terms. X and y are two different variables. So using the commutative property of addition, I can rewrite this problem to look like this. Parentheses x plus 14y parentheses plus 22y. All I did was flip the order of the x term and the 14y term. So now using the associative property of addition, I can group the like terms alike and group the 14y plus the 22y. So now we can combine like terms to get 36y. And then we can drop down the x and the plus sign. And we can't combine further because this term has an x and this term has a y, so you can't combine them. But please know that x plus 36y is equal to the original problem that we came up with. Those are equivalent expressions. They just look differently. So pause the video and complete the got it problem, and we'll discuss this answer in class tomorrow. So now that we've completed this lesson, go ahead and self-rate yourself and let us know how you feel. If there's any part of this video that you do not understand, please rewatch it again. Also, come to class with some questions so we can discuss it in further detail.